Hey everyone, good evening and welcome to our session today. Before we begin, as always, I just want to make sure that you're all able to hear me properly and see the screen. Any one of you can just let me know. If so, we'll go ahead and begin right away. Right, perfect. Yes, glad to hear that. So, welcome to today's sessions, guys. At these hours from 9:30 approximately, we're going to go ahead and take a look at uh, the kind of questions you can possibly expect when it comes down to TCS Digital. Now, we know that when it comes down to TCS Digital, it's basically going to be, hold on, guys. All right. So we know when it comes down to TCS Digital, there's going to be, this is particularly, I'm talking about only technical round, not the other rounds, where we have a 60-minute round where two questions are going to be given. And these two questions need to be solved within 60 minutes. So basically, so you can solve it in any programming language you choose to. That's completely your option. But the idea is that you'll have 60 minutes to solve two questions. And the way you need to solve is as follows. So 60 minutes, two questions. This must be solved in two methods, two ways. One is time efficiency, another is space efficiency. Your most important concentration should be on time efficiency because think about this. There are 40,000 people. Let's just assume there are, let's say, 10,000 people attending this interview, out of which, let's say, 5,000 answer a particular question. But out of 5,000, who were able to answer the question so that it runs the fastest? Who were able to answer the question so that it takes the least memory possible? Who were able to provide the solution at the quickest time possible? All of these matter a lot. All of these things matter a lot. So that's why I particularly state that space, time complexity, and all these things matter a lot. And followed by this, there are test cases which you need to fulfill. There may be some test cases which you may need to fulfill. And if you miss out on the logic for the program in the right way, some of your test cases may not work out properly. That's something which we need to look at as well. So all of these three things are hugely and equally important when we look at solving problems for this purpose. Now, here's what we're going to do today. Today, we're going to take a look at a couple of simple questions that have been asked previously in TCS Digital and the kind of questions that you can expect generally when it comes down to TCS Digital. This is exactly what we're going to do. So let's take a look at this. So first thing to begin with is, so you don't have a limitation that you have to answer in only certain programming language. So it's not like you have a limitation that you have to answer in C only or C++ only or Java itself or only Python or something like that. There's no such restriction. You can answer in any of these as possible. That's the whole idea. You can answer in basically any of them. So I have a couple of questions before I go ahead. So let me just take up these couple of questions. We'll be going through all these languages, don't worry. And the questions you can expect could be, generally, most of the times, could be based on simple data structures like map or hash table, or not even that complicated. Simple data structures like even arrays, you may expect a lot of questions because time given is 60 minutes. It's not like Code Vita who ask you very complicated questions. It's not like that. Most of the times they're going to be pretty simple programs, just slight modifications. That's it. So let's take a look at this. Again, I have one question. What about the requirements? For requirements of TCS Digital, they have put it in their website, if I'm not wrong. For TCS Digital, you can give it a check. You can, when you're applying for it over there, you can just give the same thing a check, like what sort of backlogs are allowed and not allowed and everything else. So most of the, let's say, entire branches are allowed. I have one question. Do they ask based on dynamic programming? They could. So Okay, so let's go ahead with one of our first problems. At Kaiser's question, I'll make sure to try as much as possible. All right. So let's go ahead with a couple of questions today and try to see if we can solve something out. At Sarah's question, I'll let you know as soon as possible. I haven't gotten info on that yet. I'll let you know. It'll be on the portal, but where exactly, I'll just let you know. Right, I have one question before I go ahead. What if one or two test cases fail? Then you just have to hope that others haven't done better than you. Most others have not done better than you. And I have a couple of questions before I go ahead. At see, let me just point out. Okay, see guys, digital is easier compared to Code Vita. All right, Code Vita has much tougher problems and it takes longer amount of time to solve them. Digital is not difficult in terms of programs. So you have your round one in digital. I'll just explain this very quickly so that I don't take up too much time so that we can directly go for a couple of programs. Round one is where you have your online round. This is where your in technical part, your coding round comes up. Round two is where you have your face-to-face interview, where a lot of things are asked when it comes down to latest trends, technologies like ML, AI, or something like that, and what are the programming languages you know, things on DBMS, things on, let's say, your favorite subjects, object-oriented programming, all of these. So I'm only talking in terms of technical. All right, aptitude separately, it's there as MCQs, and there's a verbal part also, but I'm only talking about coding and technical part. All right, in our session, we'll only focus on these. All right, so round one is basically entirely online. Round two will be your face-to-face HR. So I have one question before I go ahead. That is, if you prepare for digital, will it be easy for NQT? See, here's the simple thing. NQT has a combination of MCQs as well as programs. Whatever you prepare for digital may be helpful for programs, but it won't be helpful for MCQs when you go for NQT. You have to prepare very differently for those. Right. Our regular sessions that we hold will help you out a lot for that purpose. So I hope I've been able to answer all the questions. Yes, you'll be able to get the recorded sessions as well. Don't worry. I think you will be. I'll confirm that as soon as possible. All right. So as far as I think, you will be. So let us go ahead and at Kaiser, not sure. I'll confirm. Right. So let's go ahead and continue ahead over from here. So first thing, when we talk about let's say TCS Digital, here's the first thing. Here's the basic things that you need to know when it comes down to this. Just remember, you only get a program. There are no MCQs. I'll repeat, you'll only get a program. There are absolutely no MCQs. Since there are no MCQs, you don't have to worry about learning so much other than that. So, so towards everyone who's asking about the recordings, I'm not completely sure. As far as I'm assuming, it will be in the portal. All right, it will be somewhere in the portal. Where exactly? I think Himanshu sir will be able to help you guys out through that. All right, aptitude will be there. Aptitude MCQs will be there in round one as well. In our sessions with me, we will only be focusing on technical. All right, technical will be the coding part. Aptitude and verbal will also be there in MCQs, but in our sessions, we'll only be focusing on our coding technical. So with that clear, let's go ahead. I have one final question. Who will be eligible for this? See, you need 60% minimum aggregate, no backlogs, and a lot of branches. Lot of different branches are allowed. You can take the list of the branches in the website of TCS that's available. I think it's CS, EC, EEE, Mechanical, Applied Science, MCA, MSc, everything is there. All right. So all of these scenarios are there. So you guys can give it a check. Also, one more thing, please remember, if you go through let's say NQT and you do really well, you will ensure that you're doing really well in NQT, exceptionally well, according to TCS. Then you have a chance to go through second round of digital directly. So I have a couple of questions before I answer. I think there's a lot of misconceptions with us. There's no such thing called cutoff. It's a top n number of students that they're going to take. How many? We don't know. It depends on the projects the company has. Right. So there should be no current backlogs, active backlogs. Right. So there's no such thing. So I hope that's clear. So let's give this a try. Let's take a look at a couple of programs, and you guys will be able to understand whether you will be able to solve them, how such questions come up. You'll get a really good idea when we go through a few programs. I hope we can do that now. It's for 7 lakh per annum package. All right. So shall we go for the first program? What do you guys think? Yes. So at the question that even if I'm a beginner, can I crack it and everything, you'll get to understand over here. So here's the question that I'll give. Let's see how many of us will be able to figure this out. So given, sorry, given two input arrays, which are sorted, you need to mm, you need to create a single sorted array by, let's say, combination of the two input arrays. That is, think of this. There are two arrays of length m and n. I'll just give you some example. Again, I'm not going through the entire question entirely because we will be able to understand by looking at this much. So the idea is that you're going to get two arrays to begin with. But Chandan, it's online. You can apply. Right. So you're going to get two arrays like this. I'm going to get first array as 1, 3, 5, and 7. Second array as 2, 4, 6, 8. Now, all that you need to do is combine them. Please remember, combine them. At Sahana's question, please do post again. I don't think I was able to see the question. You just have to combine them and sort the combined array. That's it. Now, what are the methods we can possibly use? Think of this. They will give a question, something like this. Let's say I'll give you input will be something like this. First input will be two numbers, m and n. That is, m will be the size of first array, n will be the size of second array. After entering size of first and second array, we then need to read the entire arrays. So to read the entire arrays, they will enter array 1 elements and then array 2 elements of size n. This is of size m. Now I have a lot of different answers coming up. All right, let's try figuring this out. Let's see which will be the best method to solve. And output according to this will be a sorted combined array. Now, let me ask you guys one thing. Can I add these arrays together and then perform sorting? Will this work? Can I add these two arrays together and then perform sorting? Simple logic, right? It should work. It works. Now, this is where we need to start to learn and think about time complexity. Hey guys, is this array going to be sorted? Let's add them. First, let's combine them. I'll take 1, 3, 5, 7, and 2, 4, 6, and 8. What is the minimum time complexity required to sort an array? When it is unsorted. I'm talking about when it is unsorted, minimum time required to sort an array, not when it is sorted. We know it's not sorted. It is when it's unsorted, minimum time required is big O of n log n. Please remember, big O of n square is different, big O of n is different. For those who may be confused here, please remember, big O of n is the best case scenario in certain sorting algorithms like bubble sort. This is the best case sorting time complexity when the array is already sorted. But our array is not sorted. So that is best time complexity, not worst. So it should be omega. So worst time complexity with some, let's say, sorting algorithms like quick sort and merge sort and everything have n log n. This is what they have. Now remember, n log n is greater than n because you are multiplying n with something that is log n. This log n value will be, of course, some value greater than 1. Since it will be greater than 1, whatever you're going to multiply is going to be greater than big of n. That's why we say that big of n log n is a worse time complexity compared to big of n. Compared to big of n, this is worse. Compared to this, big O of n square is even worse. So what I'm going to do here is say that if you want to use any time complexity, if you want to use, let's say, any sorting algorithm after combining the arrays together, you're going to have to use minimum big of n log n. Minimum, this is what you're going to have to use. So to prove that, I'll just show you a little case here. At Sushma's question, it's the same thing. The lower bound is also same thing, upper bound is also same thing. Because it has to go through so many repetitions in material. Right. So just observe this. Right? Let me try to open this particular website. I think there's something wrong. So let's give this a check. So I'm just trying to figure out if we can find this. Just hold on, right? So that I can show the same to you. If not, don't worry. We'll directly go to our code. No need to worry about it. So one question: do we need to pay some amount of registrations? I'm not sure how it's going to be this year. Last year there wasn't any, as far as I remember. I'm really not sure how it is this year. Right. So what are we practicing? Yeah, we're going to practice some programs. I'll show you guys how we're going to solve this. Don't worry. So if you guys observe here, worst time complexity in all of these is worst. The best in the worst case is n log n. There's nothing that is big of n. But observe the question. The question is that two arrays are already sorted. The idea is that both of these arrays are already sorted. Now, if I combine these two as it is, like 1, 3, 5, 7, 2, 4, 6, 8, am I not making it worse? Isn't it an unsorted array now? Of course it is. I'm making it a little worse. So there's a better logic to solve this. There's a slightly better logic to solve this. Let me show this over to you guys. See guys, what's the size of each array? Observe this. For you to solve in better time complexity, sometimes you may need to take more space, more memory. That's what we're going to do in our program here, because most interviews talk about time complexity. They don't care much about space complexity. They do care, but the priority is always time complexity. So what I'm going to do here is look at the size of first array 4. Look at the size of second array 4. So I'm going to add them and I'm going to create another array of size 8. I'm creating one more array of size 4 plus 4, that is 8. So let's do that. I'm creating one more array of size 4 plus 4, that is 8. Now I'll tell you guys how we can solve this without using this extra size also. Don't worry. We can even solve this literally without using this extra size. I'll take 0, 1, 2, 3, 4, 5, 6, and 7. Size 8 array is created. Now, observe guys. The first array is sorted. The second array is sorted. Since both of them are sorted in ascending order, can I say whichever is the smallest of the two elements, whichever is the smallest of the first elements will be the smallest of both arrays? Because both are sorted. Since both are sorted, first element will be smallest always. It will always be smallest, first element. So whichever is smaller out of these two first elements, I can say that's the smallest element of our entire array. I have one particular question before I go ahead. There is, will they mention question what time and space complexity they're expecting? Sometimes they do, sometimes they don't. It purely depends on them. Sometimes they have, sometimes they wouldn't. And some test cases won't be visible as well because they want you to struggle a little, because they want to check how good you are when it comes to your logical ability. That's also there. But let's go ahead here. Now, this is what I'm going to do. I'm going to assume that we are going through array 1 and 2 simultaneously. Let's take an index called I for array 1. I'll just use uppercase I so that I can move it here. And I'll just use something like J here. I'll just use something like K here. Observe guys, I is the index here, J is the index for our second array, and K is the index for our third array. Now, first thing I'm going to do is check out which is smaller. This is our array N1, this is our array N2, let's call this as our array N3. Is N1 of I smaller than N2 of J? Yes, it is. N1 of I is smaller than N2 of J. So this must be the smallest element of the entire thing. So what we're going to do here is, since this is smallest, since 1 is smaller than 2, we're going to copy 1 over here. After we copy 1 over here, we're just going to move this index and we're going to move this index. Why? Because we have already copied the first element of our first array over here. Why? Because that's the smallest element. We want to create a sorted array. At Praveen's question, we are just trying to figure out how to sort these two arrays after combining them in the best time complexity. Now, once this is done, can I say next smallest element of both of these or the smallest one between these two? Again, N1 of I, N2 of J. Can I say same thing again? Because again, they're in ascending order. We have already removed this. We have already removed 1. Let's forget that. The next smallest element will be either 3 or 2. Whichever is smaller, that is what I have to put here. Can I say this? Is this correct? Is this idea right according to you guys? You can let me know. Correct. Absolutely right. So now some of you are saying that this logic will fail. Let's see what happens. Let's see. So which is smaller out of this? 2 is smaller. So what I'm going to do here is copy 2 over to our array. And I'm going to increase this index and I'm going to increase this index as well. So both arrays are given as sorted. Both arrays according to input is given as sorted. That's why we are performing this. Now, I is also here, J is also here. Let's compare again both of them. Is N1 of I less than N2 of J? Yes. So let's copy from I over to K. I'm going to copy here. I'm going to move I and I'm going to move K. That's it. Done. So let's also assume that these are done. Now, again, now I'm going to compare if this I and J, which one is lesser? Index J is lesser. So I'm going to copy that over here, move J by 1 and move K by 1. Done. Now, after that, I have to compare the next I and J value. That is 5 and 6. 5 is lesser. So we'll move I by 1, move K by 1 only after copying 5 over here. Done. Now let's try again. I have J as 6, I as 7. N1 of I is 7, N2 of J is 6. Which is smaller? Of course, N2 of J is smaller. So we're going to copy that over here, move the value of K and move the value of J. Now let's compare again. What is N1 of I and N2 of J? When we compare this time, N1 of I is lesser, so we'll copy that and move I and move K. Now, if you guys observe, I have one question. What if both are equal? Copy any one of them. One after the other, you have to copy. So you can copy any one of them. That's completely your choice. So I will give a condition either lesser than, less than, equal to, anything matters because you're just copying one of them. If you give less than equal to, first one will be copied. If you give only less than, second one will be copied. That's the whole idea. Now, if you guys observe, I has crossed the length of N1. What was the length of N1? M. What was the length of N2? N. To all the questions that I'm getting as if both arrays are not sorted, the question in our interview is that the arrays are sorted. You have to solve based on that with the least time complexity. We'll solve this. Then we'll go for not sorted. We don't want to move away from the current program to something else and then go back because we're in the middle of a lengthy program. I hope you guys understand. So now, if you guys observe, I has crossed the limits of range of array N1. So what do I do? Since it has crossed the range of N1, should I consider this array anymore? I don't have to. I should only consider elements of second array. So here's the logic. If one of the array is completely done, you copy second array remaining elements to your final array. That's it. If one of the array elements are completely copied, one of these array elements are completely copied, you just copy the elements of the second array. That's it. So yes, this logic is somewhat similar to merge sort, but we're gonna make an improvement on that. So this is not pseudocode; it's only coding ground programming. All right, you have to solve the program in a particular language. So it's not about the number of lines you write in the program, it's about how much time it takes for that program. All right, it's always not about the number of lines. Some program may have smaller lines, but the logic is going to be longer due to inner for loops and everything. Some programs will have longer length, but its logic will be much smaller. So this is what we're going to try to figure out. Yes, you can get to choose your language. It's something we have gone through earlier. You can. So when one of the array is completely done, we copy the second array elements all the way over. That's it. That's the entire logic. So let's copy elements of our N2 array all the way over. There's only one element remaining. That one element itself I'll copy. That's the end of it. We are done with it. This is our logic. Is this simple, guys? So the worst time complexity here will be m plus n. M is the length of n1, n is the length of n2. And after that, remember, you're also displaying this array. To display this entire array, you're using a for loop again to display entire array, right? So even considering that, you can say it is big of m plus n plus n plus n, or in other words, 2m plus 2n, or 2 into m plus n. You can say that. Now, here's what I'm going to do. We're going to make sure that it's going to be much, much smaller, not much, much smaller, slightly at least smaller than this. So let's take one scenario. Right. Now, let's start with this. First thing we're going to do is try doing this in C++ very quickly. Very easy logic. Don't worry, we're going to be able to do this very, very quickly. So let's start with void main. Sorry guys. Since I would always prefer C++ rather than C, so you guys can go for IOStream for C++ and using namespace standard. We'll do all, don't worry. Now, observe here, guys. So the first thing here is that, guys, don't worry, same thing here. All right. So first thing you guys need to know, no, observe. Again, yeah, of course. Since it's C++, we need to use int main and we need to return some number. It's not C. Let's return something. Done. Now, let's go ahead here at Triveni. Yes, it is. Now, let's go ahead here and take a look at how we're going to solve this. So what's the first two inputs we expect? Two values, two numbers m and n. So let's read two numbers m and n. I'll take int m, comma n. Now, along with this, we need to read two arrays. Now, there are multiple ways for you guys to read entire arrays. Now, please remember this. Since you want to read arrays, you can either create an array like this, like int a of 100 and let's say b of 100. That means you're creating an array of larger size. What if user only enters array of 4 or 5 length? Then the rest is wasted, right? We can't use that. And on the other hand, in every scenario, I can't also use int a of m and a of n. In every scenario, we can't use that as well. So we need to find a different way. There are two ways for you to solve this. At Abhishek's question, this is to ensure that you're able to print and read, use print and read statements. That is seen and see out statements. I think we are going through that. We have gone through that in our live sessions. If you haven't gone through them, you can go through them. Or if you're from batch 17 by chance, we will go through them ahead. But just for now, remember that it's to read, to make sure that you're able to use C in and C out. That is input and output statements. All right. Don't worry, it's going to be pretty easy. Now, one of the simple ways that I will explain is to use malloc. You can use malloc to dynamically allocate memory, but I'll give you guys a better method. And this is the one that I prefer when it comes to C++, because you get to show that you get to also prove that you have the idea of data structures within C++ as well. So again, you can create an array using dynamic memory allocation, like for example, something like this: int star a equals malloc size of int into m, because there's supposed to be m elements, right? Since there are supposed to be m number of elements, you can multiply size of int with m. It's gonna create this much big amount of memory space, and it will give it to you. which you can store in A, which is a pointer, which basically means it's an array. So this is how you can store it in one way. Since it's an integer pointer, you have to convert it to integer pointer. So this is basically, again, at Saurabh's question, we have, I think we have gone through it in our session. You can check through it. If we haven't, not to worry, I'll again go through it once, not to worry. So just remember, malloc is an inbuilt function which can help you create a memory of the size required for you. How much bytes do you need? Size of int into n. That much bytes you need to store array A. Similarly, how much size do you need for array B? Same thing into n. This is how you can create the array A and B. So with this, you can access arrays as A of 0, A of 1, A of 2, A of 3, and so on. But there's another way. At Arun Kumar's question, yes, we'll do that. Called vector. For those who don't know, remember this. Vector is where is it? Vector is a container that organizes elements in a type of linear sequence. It enables dynamic addition and removals. That means its size is gonna change as per it requires. So if you want to add one more element, its size will change. If you want to remove one element, its size will change. So you can use a vector in order to do that. So this is a very good way to make sure that you don't have to use things like let's say, how do I say, malloc, calloc, or anything. You don't have to do all of that because vector does it internally. You don't have to worry. It will automatically increase and decrease the size by itself. That's one thing you need to know. So let's take a look at this vector and see how we can work through this. We'll go through one language at a time. At other languages, I'll answer them ahead. Don't worry. For all the questions on other languages, I will answer them ahead in time. But first, let's take a look at this language, right? So I'm going to create a vector of integer. Let's call this as array n1. We'll create one more vector of integers. We'll call this as array n2. That's it. Now, once we call this as array n1 and n2, our dynamic sized arrays are created. So we can change the size of these vectors however we want. There are a lot of functions within these vectors that we need to create, that we can use. There's no array. This vector itself is our array. Please remember, this vector itself is our array. Vector is a special class in C++ which creates array for you. Right. We are creating two arrays called n1 and n2 in the form of vector. Vector means its size is automatically changeable. It will dynamically change the size depending on how many elements you're entering. So you don't have to worry about the size at all. That's the advantage. So that's why we can directly use like this. I've given you both solutions. Previously one solution and now previously using array and now using this. So let's try using vectors and see how we can read the elements. Now, let's try reading these values. At Pavitra's question, it's their own platform, right? So let's try to read elements. So I'm going to go through again. Since we need to read elements, I'm also going to use I. So I'm going to go through for I equals 0, I less than n, I plus plus. So this is where I need to enter values in the vector, right? Like total m elements I need to enter in vector n1. Similarly, I need to enter n elements in vector n2. Remember, m in n1, n in n2. This is the number of vectors we're going to use. So we have declared I right here. Right. Now, to enter elements in vector, we don't just use something like, let's say, n1 of I is equal to our integer value or something like that. We don't use this. Instead, we need to use a function called push back. Because vectors are slightly different. Vectors are a class. They have their own functions. They have a particular function called pushback. Pushback function adds an element at the end of the vector. I have one question, is it mandatory to use C++? No, you can use C++, Java, Python, C, anything. But I would always prefer not to learn through C only because when you require some data structures to be used, you have to know C++. That's why I'm starting from C++. So don't worry, it's going to be an easy thing. I'll explain this entirely. So I'll be sending all the content. Do not worry about it. All right. So observe here, guys. We have a function called pushback, which adds an element at the end of the vector. Now, I have one question. Using vectors already, we have created n1 and n2. Why do we need m and n? See, do you know how many elements are going to be for your first vector? Do you know how many elements are going to be for your second vector? If you don't know, how will you know to differentiate? Vectors only create dynamic arrays. Vectors only create arrays of arbitrary size. They can increase to any size as long as there is memory available in your computer. But how will you know when you should end the first array and when you should begin the second array? You don't know, right? That's why we need vectors. I hope that's very, very clear. That's why we need m and n as our input values. I hope that's clear. I have one more question. Will there be any limitations for using inbuilt sort functions? As I've stated earlier, when you use inbuilt sort functions, it takes minimum n log n. Whether you use inbuilt sort functions or your own sort functions, you need to combine these two arrays into a single array, and you can only give a single array as input to sort functions. So that will take minimum of n log n. We are doing it within n. I have one question. We haven't initialized m and n. We'll do that. Don't worry. We'll do that. So n1 and n2 will create arrays. M and n will give size. Yes. M and n are just for reference of size. All right. Now, putback is the function to read elements. Now, first let's try to figure out the reading of elements. Now, at Sneha's questions, it's same. There's no difference. All right. Now, to read m, I'll just use C in m. Yes, you can use STL. All right. And I'll also use C in n. Now, C in is used to read inputs within C++. Right. So let's go ahead from here. Now, first thing I want to do, I want to inform you guys is yes, you can use standard template library. You can use STL. So you can use scanf also, but it's easier with this. I prefer to use this. You guys can compare and check. All right. So we are reading two variables m and n. I have one question. How about we change the array of change size of first array, then run through elements of second array for each element. We run through first array and make replacement of this range of numbers. Okay, let me try to understand. I'm kind of confused reading this. Hold on. How about we change size of first array, then run through elements of second array, and for each element we run through in first array, make replacements. See, when you say you make replacements, how are you going to manage it? How are you going to do that? When you want to say you're going to replace in first array, think again the logic. Please think to everyone, please think of the logic. Please think what logic you're using here. If you say you have elements of first array and you want to enter second array elements also in first array, if I want to enter 2 here in the sorted part, shouldn't I move 3, 5, 7 ahead? Isn't that taking more steps? That is taking more steps, right? If you're taking only 2 arrays, you want to move second array into first array and combine them. To move 2 here, you have to move 3, 5, 7 ahead. To move 4 here, you have to move 5 and 7 ahead to their next indices. Observe, index 0, 1, 2, and 3. If you want to move 2 here, you should move 2 here, right, to index 1. That means 3 should go to next index, 5 should go to next index, 7 should go to next index. Otherwise, you lose those values. So I hope you get now as to why we do it in the way we are doing it right now, to save time. The way we are doing it, the logic we are using is to ensure that we are saving as much time as possible so that our program will execute in the least time required. Right. So pushback is a function which puts an element to the end of the vector. So what we're going to do here is just use something like int temp. We're going to take a temporary variable and we're going to use C in temp. I'm going to make sure temp is over here for our easier understanding. So we're just going to take some temp variable. We're going to say C in temp and we're going to use our vector. First one is n1 dot push back of temp. Whatever we are reading, we are adding to temp. Similarly, second time when we do this for n elements, we do the same thing for Second, at Redmi's question and at Samsung's question, I hope it's very, very clear. I hope it's very, very clear. At Anusha's question, yes, you can do that as well. There's no problem in doing that. Right. So I hope it's clear for all of you guys. Now, here I have to push the elements in N2. Now, if you observe, N1 will have M elements and N2 will have N elements. To prove this to you, I'm going to take one more for loop. I equals 0, I less than M, I plus plus, and I'm just going to print here. Sorry, instead of printf, we can also use here, both are same. I'll take N1 of I. Similarly, temp is just a variable where we are storing it temporarily and then pushing that variable back using pushback function. That's it. So we are printing both arrays. Let's see what exactly happens. I'll print here array 1. I'll also print here array 2. Right. Now let's give this a check. I have one question. Yeah, this will be less than n. Right. Now let's see whether it works. Now let's see if it works first. Yes, one at a time. We'll go through one at a time, one language at a time. All right. So let's try compiling this. Since it's a C++ code, I'm going to use G++ code dot. I need to again copy it. I'll just do one thing. So let me open the C++ file where I've copied basically the same thing. Yeah, because we need to run it as a C++ file, right? So let's compile this and let's run this. Now, I've missed out a couple of semicolons here. Let's add that. Done. And let's see what else is missing. Yeah, that's the one. So now let's compile this again. There's one more semicolon again. See out, I've missed out semicolon in both places. Let's add them. I have one question. Yes, notes, video, everything will be provided afterwards in the portal. Do not worry. All right, both will be provided. Temp is just a variable where we are reading and then entering it into our vector. That's it. Now, let's quickly compile and see if we are able to get our values. So let's try it out. Let's run it. So first thing I'm going to enter is number of elements. I'll enter 4 and 5. That means 4 elements in our first array, 5 elements in our second array. So first array will be 1, 2, 3, 4, and second array will be 5, 6, 7, 8, and 9. Now, if you guys observe, you're getting first array as 1, 2, 3, 4, and second array as 5, 6, 7, 8, 9. This is exactly how we have it. So is this so far clear? Pushback will enter the element at the end of the vector. So first value enter will be entered at the end of vector. Initially vector is empty. So vector will only have 1. Second time it runs, 2 will be entered at the end of the vector. Vector already has 1, 2 will be added to the end. That's how then 3 will be added to end, 4 will be added to end. Pushback is like that. It adds an element to the end of the vector. That's it. I hope that's very, very clear. So at Vishal's question, as many as possible. We'll look to that, as many as possible. Now, let's go ahead with this. I'm just going to comment this so that you guys can check this out later on. So now let's go ahead and work through this, shall we? Perfect. Now, I have a couple of questions. What is the use of temp? See, you're trying to read an input and then store it somewhere, right? You're trying to read an input and then store it. Is pushback a variable or a function? It's a function, right? Can I input something into a function? No, I can only input something into a variable, right? That's why I'm inputting into temp and then temp I'm putting it onto pushback. I hope it's very, very clear. You're taking the input like this. There is one more way to do it. There is, you can directly take, this is the only best way. I'll just point out, no need to, for us to worry about it, because vectors are dynamic arrays which have functions. They don't have n1 of 10 equals some value, n1 of 20 equals some value. You can't use cin as it is directly. So that's why we are storing it in a temporary variable and then adding it to our vector. It's not like a regular array where you can just use cin and n2 of 5 or something like that, because initially you don't know the size, right? That is why you're adding one element at a time at the end by increasing the size automatically. That's what's happening here. I hope that's clear. Now, let me ask you guys one thing. User will enter two arrays. After user enters two arrays, I'm supposed to add them, I'm supposed to combine them and sort them. Now, once I combine, Raghava's question, give it a check. You can let me know what happens. All right. Now, let me give you guys one question. Please observe this, guys. You can't use cin temp directly in here. Just don't do that. That's not gonna work. Cin doesn't return temp. It doesn't return anything. That's not how it works. All right. Every function is different. So please don't use that. Okay, that will not work. But let's go ahead here. Let me ask you guys. Into these two arrays, we're supposed to combine them and sort them. Now, let me ask a very quick question. When I combine at Sahana's question, can you let me know which part is confusing so I can explain it? You can let me know. All right, now let me quickly ask you guys. There's only going to be two input arrays, right? There's not going to be more input arrays. So how many times am I going to combine them and sort them? Only once. Since I'm only doing them once, please observe this. Since I'm only doing them once, do I need a function? My question to you guys. Since I'm only doing it once, do I need a function? I can do something like c equals a plus b, or I can do c equals sum of a comma b. When I do sum of a comma b, it's going to go to some function, it's going to send these two variables, it's going to create two new variables, it's going to add them, and it's going to return the result, which is going to create more time spent, a little slightly more time spent. When do we need to do this? When we are repeating the same steps again and again and again. When we repeat the same steps multiple times, then we need to send these arrays to a function, and in that function we need to combine them and give back the result or something. Here we don't need to use a separate function because we are performing this step only once. That's the whole idea. At Arathi's question, maybe in some other session we'll do that, but this is the interview question we are going through right now. That also I'll take up, don't worry. All right, so far what we have done right now is created two vectors called n1 and n2. N1 has our first array elements, N2 has our second array elements. We're just supposed to combine them, and after combining them, we just need to print the result. That's it. Now, let me ask you guys one thing. See, when I combine them and store in a different array, can I use a vector as well? When I store the result in a different array, I can of course use a vector as well. So what I'm going to do here is, of course, we can use an array or a vector. That's completely our choice. That's purely our choice. Don't worry. We can use an array or a vector, completely our choice. Now, here's what I'm going to do. In this case, I'm going to create one more vector. And whichever is smaller in both cases, I will push it back to the vector. I will use again the same function, push back to our new vector called n3. Now, when I push back, what happens? First, I'm entering 1, then I'm entering 2, then 3, then 4. It's going to push in the same, it's going to enter in the same order in which we call pushback function. So we're going to do the exact same thing. Again, at Gungon's question, it's basically array, right? Same thing. Anyway, size of the new array will be sum of two arrays. Yes, you can do it either way. That's completely your choice. I will make it as a vector because I want you guys to understand and experience how exactly these sort of standard template libraries work. At Subaraja's question, there are no pseudo codes in this. All right, TCS Digital only has a coding round. Okay, there's no pseudo code based MCQs or anything here. I hope that's clear. That's why we're only focusing on what can be asked in the TCS Digital's first round. That is our major concern. I hope you can understand that. Right. So now, yes, iterators can also be used, but I don't want to complicate things in the first session. Maybe in the coming sessions we'll do that at DP's question. Let's go ahead and continue ahead here. Here's the next thing that we want to do. We have two arrays. We need to go through both the arrays. Now remember, guys, I need to go through both the arrays until which condition? Can you guys tell me? Until which condition? Which is the condition in which I'll go through both the arrays? I'll take two, let's say, integers, I and j. I'll take two integers, I and j, until the arrays are complete. I need to repeat until arrays are complete. Now, let me ask you guys one question. What if one of the array is completed? What if one of the array is completely done? If one of the array is completely done, I need to copy only the other array. I shouldn't think about this array. If n2 is completely done, I need to only fill the first array. I don't need to think about the second array. So there are three conditions that come here. First condition is when both array have elements. Second condition is when only n1 has elements. Third condition is when only n2 has elements. Because the logic we do for all three are different. When both array has elements, we need to compare them and check which is lesser. When only n1 has elements, one of them is done. I need to copy only of n1. Otherwise, I need to copy only of n2. How will I know that both have elements? I'll check. I'll use a for loop. But before that, let us declare a couple of variables we need here. I'll use one more variable called j for our purpose. So I'm going to use I equals 0 and j equals 0. Remember, I indicates starting index of our first array. I indicates starting index of our first array. J indicates starting index of our second array. So I'll just point out very quickly here. J indicates here, I indicates here. Now, let's start one thing at a time. So, how will I ensure that both arrays are not empty? Or how will I ensure that both arrays are not completely checked? I need to use a loop. I need to use a loop which we can repeat. Yes, as one of you pointed out, you can even write this code like this: I equals j equals 0. That also works. Both are the same thing. It doesn't make much of a difference. Now, I need to give a condition to ensure that I does not cross the limits of n1 and j does not cross the limits of n2. So for that purpose, can I take a simple condition while I less than m1 and j less than n2? Sorry, not m and n. I'll take m and n. Can I do this? M is the number of elements in our array number 1. Let's say 4. I is the index here. I will range from where? 0, 1, 2, and 3. The moment I reaches 4, that is the moment I is equal to m, I should stop here. That means array 1 is done. Similarly, let's take n2. In n2, let's say n is again 4. Since n is 4, indices are 0, 1, 2, 3. The moment index j reaches crosses 3 to 4, 4 with its size of array n2. Then I can say we are stopping right there. Second array is completely done. So can I use this logic? This is the condition where both arrays are not empty. I is iterator for array n1. J is iterator for array n2. So this is what we're going to use over here in our program. So let's give this a try, guys, very, very quickly. While I less than m and j less than n, what do I need to do? First case, I is 0, I is pointing to index 0, j is also pointing to index 0. What do I need to compare? So of course, I need to compare n1 of I and n2 of j, which is lesser is what I need to check. Absolutely right. So let's do that. If n1 of I is lesser than n2 of j, then what do I need to do? I need to add n1 of I to our resulting array, right? What is our resulting array? N3. So I'm just going to push n1 of I to n3. I'm just going to use n3 dot n3 dot push back of n1 of I. Remember, pushback is a function. That is why I need to use these brackets, not index brackets, not the square brackets, because pushback is a function. It's not an index. All right. So I'm adding it to it. Now, after adding it to it, I need to increase I value, right? I should go to the next value because we have already copied one over here. That is done. First element is done. Since it is done, I just need to push back n1 of I, then increase I by 1. Instead of making it as two separate statements, I can also combine them by writing post increment here. Does it make a difference? Absolutely no difference. It's the same step. Now, second scenario, else if n1 of I is not, now first case is done. Other scenario, if n1 of I is not lesser than n2 of j, whatever is n2 of j, I have to copy over here and I have to increase j. So I'm going to do the same thing here. This time, else n3 dot push back of n2 of j plus plus. Now, you may ask a question, what if they're equal? If they're equal, remember, it will go to else. When two numbers are equal, it's gonna go to else because our condition is n1 is less than n2 of j, not less than equal to. If they're equal, it's gonna go to else. Since both numbers are equal, it's gonna push from secondary. That's it. This is our entire logic. Now, this is when both arrays are not empty. Now, if the while loop is done, there is a chance. Now here, there is a chance that one of the array is still empty. I have one question. Suppose I'm not using vector, then yes. If you don't use a vector, if you use an array, for all of those who say if you don't want to use a vector, if you want to use an array, you just have to use something like n3 of k plus plus equals n1 of I plus plus. So n1 of I is copied to n3 of k, and then I also increases, k also increases. That's what you have to do. That's it. I have a question. Is there a chance of exact same previous year coding questions repeating? Absolutely no way. All right, there's absolutely no chance. Now, let me ask you guys, when both arrays are not empty, that is the case. Now, after that, there are two conditions. One condition is n1 is not empty. Other condition is n2 is not empty. Now, observe this condition, guys. This is while I less than m and j less than n. We need to check after this whether I has crossed m or j has crossed n. We need to figure out which one is still pending, which array is still remaining. So I need to use separate conditions here. That is, for n1 is not empty, I need to check while of I less than m. Similarly, for n2 not empty, I need to check while j less than n. So these both conditions we need to check separately. Now, what do I need to do while I is less than n? If n1 is not empty, I have to copy from n1 to n3, right? Similarly, if n2 is not empty, what do? I have to copy from n2 to n3. That's our entire logic. That's all, nothing else. So this will give us the entire result in our N3 array. So first, we are going to check whichever is smaller out of these two, whichever is smaller, we copy here. After doing that, we then give a check. At one question that I've received, let me give you a solution. Let me give you an example. Take this for instance. I have one array N1. Let's say I have 1, 2, and 3. Let's say I have one more array N2. I have not 3. I'll take 4. I have 3, 6, and 12. Now observe here. This is I value. This is J value. First, we are checking which is smaller. N1 of I is smaller. We're going to copy that one over here. This is done. Then we're going to compare which one is 2 smaller or 3 smaller. Again, 2 is smaller. So we're going to copy 2 over here. Done. Then we're going to check if 3 is smaller or 4 is smaller. Of course, 3 is smaller now. So let's copy 3. Done. Then after 3 is done, we're going to go to the next value, which is smaller, 4 or 6. 4 is smaller. We're going to copy 4. Done. After that is done, remember, there are first array is entirely done. If first array is entirely done, what do I need to do? I need to copy elements of only second array, right? Do I need to check first array anymore? No. That's the same logic why I'm using this. When both arrays are not empty, then I need to compare. When one of the array is done, when one of the array is completely done, that is, in this case, I is not less than m anymore. I has become equal to n. So I don't need to check this condition anymore. So I only need to copy from n2. When I only copy from n2, Do I need to worry about N1? No. On the other hand, if only N1 is not empty, do I have to worry about N2? No. That's why I'm using these two while loops. Is that clear at the question by Meghana? All right. Now, once this is done, we need to print our entire array. So let's take for int I equals 0, and the length of the array is m plus n. So I'll take I less than m plus n. You can do this, or there's another function within vectors. So n3 dot, you can use size function. Size function gives you the length of a vector in C++. So each time you change the length, it will automatically update the length. You can get the current length over here. That's something you can do right away. So let's go ahead here. I less than n3 dot size, and we'll increase I one at a time. And here's what we're gonna do. Within this, we're gonna print our entire vector. So I'm just gonna use cout. Let's just print n3 of I, and let's end the line. That's it. Now let's give this a quick try. Let's compile this and run this. I'm gonna take, let's say, 4 and 5. I'll take 1, 2, 3, 4, and 5, 6, 7, 8, and 9. Both are sorted. It's perfectly sorted. I get 1, 2, 3, 4, 5, 6, 7, 8, 9. I shouldn't have used endl. I should have used just a tab space. It would have been much easier. So I'm just gonna use endl over here. Now let's quickly give this one more try. So I'll take first array as 4 elements, second array as 4 elements. First array is 1, 3, 5, 7. Second array is 2, 4, 6, 8. Our output should be 1, 2, 3, 4, 5, 6, 7, 8. And how much comparisons did we do? M plus n. We saw that from here. Now, let me ask you guys, can I cancel this one more statement? Because what we are doing here, observe guys, what we are doing here is we are storing it in one more array, right? After storing it in one more array, I am printing that array. So storing that array is going to take some size. Storing that array is going to take n plus n size. And printing that array will also take big O of n, because you have to traverse through n elements to print them. Instead, what I'm going to do here is, observe guys, I'm going to cancel out our third vector. I'm removing our third vector. I'm not keeping our third vector whatsoever. Instead of keeping our third vector, every time we are about to push back, remember, every time you're about to push back, you're pushing in the order you're supposed to print, right? So whenever I'm pushing back into the vector, instead of pushing back, what if I print it? What if I just say, instead of pushing back in another vector, what if I just print it? This will save space. What do you guys think? You're pushing back 1, then 2, then 3, then 4, and so on. Instead of pushing all these elements back in that order, can I directly print them? It makes better sense, right? It makes much better sense. We are saving time. We don't need one extra, what is that? We don't need one extra for loop to print, and we don't need to store separately also. So it does make better sense. Let's see if that logic works as expected. This is how you need to figure things out. These little things matter a lot. No, it's going to print one element at a time. That's what is question. It's only going to print one element at a time. So you don't have to worry about that. So let's give 4 and 4. Let's give 1, 3, 5, 7, 2, 4, 6, 8. Now it's supposed to print 1, 2, 3, 4, 5, 6, 7, 8 as expected. Now question, if question returns vector whole, then we need a third vector. Yes, in that case. I have one question in compiler, they will ask, give us snippets in a way which asks us to return vector. If that is the case, then you need to write a separate function. We'll learn even that. Don't worry. We'll learn all these scenarios. All right. So this is the basic idea. So I'm just going to give you one more example because one of you is not quite convinced. So don't worry. I'll give you a different scenario. I'll give 4 elements, then 5 elements. For 4, I'll give 1, 2, 3, 4. For 5, see, it's only working for sorted arrays. It's not going to work for unsorted arrays. I'll give 3, 4, 5, 10. Now you're going to get, okay, one more value, 11. Now you're going to get 1, 2, 3, 3, 4, 4, 5, 10, 11. All of them are in the right order. If they're not sorted, then the logic changes. That's Krishna's question, sorry, Radhakrishna's question. You can just observe here. If they are same, we are copying one of them. What's the condition? If n1 of I less than n2 of j, then I'm copying n1 of I. If it's equal, I'm copying n2 of j only. So this is how you can work through. So what we're gonna do is do more modifications of this program. So I want you guys to work through and try to figure out this program. I want you guys to take this program, start working through it. A lot of you are asking how to work through unique elements. You can use set in that case. How to print it in a certain formatted order. You just put instead of slash t, just something else like a comma in between. That's basically it, nothing else. So for unsorted array, you need to repeat this and so on. So terminal comments at Nash's question, this is it. There you don't have to work through terminal comments. You're going to directly have a button. In TCS Digital, you don't have to work through terminal comments. You're going to have a simple button where it will just be written like compile, run, and everything. We're going to go through the same program in other languages in the next session. All right, don't worry. So I have one question, not to worry. You can apply for this. Any one of you can apply for this. It's an easy thing. You can work through very, very quickly and easily. It's really not difficult. You can easily work through. All right. So for practicing with command line commands, simple. To compile, you use this command. Where is it? Yeah. To compile, you just use g++ space code.cpp. That's your compile. Then to execute, you just use /a.out. That's it. I have a couple of questions. We can directly apply for TCS Digital. Yes, you can. Just wait for the website to confirm their dates, and you can. So in other languages, you can do it in smaller steps, but that's not going to be efficient. I'll explain why so in the coming sessions. I have one question. What are we practicing here? Can I expect it will be asked in the technical round? Yes, that's the reason why we are doing all of this, because we can expect such questions in our technical round. All right. Yes, I'll solve this in all other languages as well. That is Java and Python in the coming session. Not to worry. Right. So we'll end the session here for this, guys. We'll catch up tomorrow in the next session. So I have one question. I had seen somewhere that merge sorted arrays can use shell sort. Will that be more efficient? How different? You can you can check shell sort program. You'll get to understand. Right. It's very different. So I would prefer not to work through C. This is better. There's no MCQs in digital. I'll repeat. It's only coding questions. All right. It's only coding questions. You can use STL. You can use STL. Not to worry. Tomorrow also timings will be same time. We're gonna work through 9:30 to 10:30 for the session. So that Kriya's question, it depends on the purpose, which I'll explain in our regular sessions in detail. Don't worry. It depends on the purpose, because for each purpose you may want to use a different thing. So I'll just share the link for you guys. This window. So at Vishal's question, I'm not able to understand that. If you can repeat, rephrase, I'll try to answer. So I've sent the link as well. If you guys want, you can give that a try. I have okay. I think the link is wrong. Let me just check. There are videos on complexity, time complexity as well in the portal. You can give it a check. I think they're in Accenture, if I'm not wrong. You can just check once. All right. So let me try to paste the link once more. I think I went wrong in some part of it while pasting it. So at Vishal's question, we have done that in our last session. You can link both. You can compile both programs together. I can do that in one of our doubt clearing sessions or something like that. In one of our sessions ahead, you can uh, compile both programs together. That is CC space program 1.c space program 2.c. Compile both together, you'll be able to access it. So let me just quickly check where exactly I went wrong in copying this link for you guys. So I've just sent you guys the link. Yeah, that's the right link. You guys can give it a check. We'll do it in other languages as well. It's immaterial of your language that you choose. It's all about the logic that you choose. So these kind of questions you can expect. So do work on them. We'll catch up with more programs on this kind in the coming session. All right. So we'll catch up ahead in the next session. Sorry guys, hold on. I hope I've copied the right program for you guys. Yes, I have. All right. So with this, we'll end. Again, I have one question. Should we write whole program or just function? It's going to be whole program in case of digital. All right. Most of the times it's going to be whole program. They may just change suddenly, but we'll learn both for our easier understanding. So data structures and algorithms videos are also there in the portal. You can give that a check at Ayushi as well. You can do that. So it depends on the college at Nash's question. I can't guarantee. So wait for the date. If colleges do apply, then fine. If not, you can apply by yourself as well. Both options are open. Okay, so with this, at Ayush's question, please check in any batch videos. It's there. Data structures and algorithms are covered in our batch videos. At Yuvateja's question, it's in C, mainly in C. Right. But in all languages, we have covered it as well. You can give it a check. Our guests will end our session today here. The programs may be different for each one of you. That's how it was in the last time. There are set of programs that you're going to get. They will be slightly different. At Anusha's question, yes, we will be doing it in the coming weeks. Not right now. Maybe in 1 week we'll start it. Not to worry. All right. So with this, we'll end our session here. We'll catch up in the next session tomorrow. So have a good night, guys. Take care. We'll catch up tomorrow.